Hello Math 1B in Geometry, I've got another video for you. We're taking one last look at substitution method and then hopefully introducing this new method. You guys will see whether or not it's more convenient or makes a little more sense than substitution did. So let's get started. On our first example right here, we've really got a sticky situation because it doesn't seem like either of these equations has an easy out to do step one. If you recall, step one for substitution is when we take one of the equations here and get x or y by itself. It's not clear which one is going to be the easiest, so I'm just going to go with the smallest number in front of x that I see. So, for step one, I'm going to take 3x plus 4y equals 29 and get 3 by itself, or get the x by itself. So if I'm going to get x by itself, I'm going to subtract 4y from both sides. 3x equals 29 minus 4y. Divide every part by 3. And I get x is equal to 29 over 3 minus 4 over 3y. Yuck. That's not a great expression to work with, but that's how substitution works. So step one, get either x or y by itself. Step two, that's where we take the second equation and plug in the new value that we got on step one. So the second equation is 6x plus 5y equals 43. Since we've got x by itself in this equation, we're taking the x out of the second one and replacing it with whatever quantity is inside here. So I'm going to write it as 6 parentheses 29 thirds minus 4 over 3y. Okay, so 6x turned into 6 times that version of x. Now you put plus 5y equals 43. And again, this is not the greatest situation for us, substitution method. I'm going to keep it as this, and I'm going to use my calculator because the fractions look a little bit scary. So 29 divided by 3. Take that, 6 times 29 divided by 3. It ends up being exactly 58. So 6 times 29 thirds equals 58. I'm going to take 6 times negative 4 thirds y. That gives me negative 8y. So miraculously, we're getting some nice, neat answers out of those ugly fractions. Bring down the 5y, bring down the 43. Now this is the point of the problem in which you would combine the like terms, the negative 8y and the 5y. And you get negative 3y. At this point, I want to get the 58 and the 43 together. So I'm going to subtract 58 from both sides. Zero minus 3y is equal to negative 15. Divide both parts by negative 3. And you get y equals positive 5. So step one, get x or y by itself. Got it. Step two, take the second equation, plug in, solve for the variable. Got it. Step three, take the equation in which x is already by itself and plug in y equals 5 right there. So I'm taking the equation that we got from step one. That's usually the nicest one to work with. In this case, not so much. Minus 4 thirds y. I'm replacing y now with 5. So I'm going to say times 5 is the same as saying times 5 over 1. So this is 29 over 3 minus 20 over 3. We got the common denominator, so we can just subtract the tops. That's 9 over 3. That's 3. 9 divided by 3. Wow. Okay, so x is equal to 3. Step 4 is rewrite the solution. So 3 comma 5. Now, in this particular system of equations, it's going to be way easier, in my opinion, to do this new method of elimination. We can avoid all these fractions and maybe simplify the amount of work we're doing. So let me introduce you guys to elimination. So you start out with 3x plus 4y equals 29, and 6x plus 5y equals 43. Here's what elimination does. Elimination says, you know, if I can make the x terms or the y terms the exact same number, but opposites, so like, 2 and negative 2 would be the same number, but opposites. If I can make these the same, I have a quick route by which to get rid of one of the variables right away. So think about this as if you're trying to find like a common denominator, all right? Think common denominators. If you were trying to add 1/3 plus 1/6 together, the common denominator on this would be a 6. So you'd multiply the top and bottom of that by 2 to make 2 over 6. So that you could add the two together. Well, something similar is happening over here. The common denominator, or we'd call it the least common multiple, between 6 and 3 would be 6. So what I'm going to do is I'm going to try to create a situation where the top gives me a negative 6x. So I'd multiply that by negative 2. But I got to multiply everybody by negative 2. So, by the way, if this isn't making sense, just please stay with me. You're going to take negative 2 times 29, negative 2 times 4y, and negative 2 times 3x. I'm going to write it in red below 6x plus 5y equals 43. So negative 2 times 3x is negative 6x. Negative 2 times positive 4y is negative 8y. Negative 2 times 29 is equal to negative 58. Once you do that, you can instantly eliminate the x's by adding the columns. So 6 plus negative 6 is 0. It's gone. 5 plus negative 8 is negative 3y. And then 43 plus negative 58 is negative 15. We've got y. And maybe this first step was a little bit confusing, but as you can see, I'm not dealing with any fractions, and it just seems like a cleaner approach. Now I've got y equals 5. How do I solve for x? Well, I can take y equals 5 now and plug into either of the original equations. All right, so what did we have? We had 3x plus 4y equals 29 and 6x plus 5y equals 43. I'm thinking that the top one, it has smaller numbers, that might be the more convenient one to work with. So I'm going to rewrite this equation. But instead of the y, I'm going to put a 5. Which gives me 3x plus 20 equals 29. Get x by itself, minus the 20, divide by 3. So what you've got here is a completely different approach by which to attack linear systems of equations. You had substitution. It was clunky in certain situations. It seems elimination can help us when substitution gets a little bit wonky. Your final answer is 3-5. And I'm going to show you guys another video with 3 examples to help you through the exercises